The same, like, switch up your conversation.
All right. Yesterday, we did a little activity to introduce these different angle relationships that we're going to look at here. It seemed like some people were a little confused by the activity yesterday, so hopefully today we'll clear some things up. Okay, so we looked at 4 different relationships. Okay, alternate interior, consecutive interior, alternate exterior, and corresponding. Right? So the basic idea is we have 2 lines cut by some other line that we're calling a transversal. Okay? So this line that cuts through 2 other lines is called a transversal. And in the activity we did yesterday, we said, well, these 2 lines are parallel. On the first side of our paper, we're just going to say these are just any 2 lines. They don't have to be parallel. We can still name these relationships whether these 2 lines are parallel or not. And they're cut by some other line. Okay, so the first thing we want to look at is what interior means when we're looking at a diagram like this. Okay, interior just means I'm on the inside of my 2 lines. Okay, interior means inside. So if I'm talking about the interior angles here, that would be 3, 4, 5, and 6. Right? Those are on the inside of my 2 lines. So then, yesterday, we started looking at 2 different types, or 2 different pairs of interior angles. Okay, the first one was alternate interior. Okay, alternate means on opposite sides. So, alternate interior angle pairs. So if we're talking about angles that are on the inside, that are on opposite sides of the transversal, I can say 4 and 6 would be a pair of alternate interior angles. Okay, they're on opposite sides of the transversal, both on the inside of my 2 lines. I could also then exactly, yeah. Then 3 and 5 would also be a pair of alternate interior angles. Okay. So then the other pair of interior angles we can talk about is consecutive interior. Consecutive just means on the same side, right? So we're saying on the same side of the transversal on the inside. So 4 and 5 would be an example of a pair of consecutive interior angles. Also, 3 and 6 would be an example of a pair of consecutive interior angles. Okay? So then, we can also talk about exterior angles. Right? Exterior angles are on the outside of my 2 lines. So if I'm looking at my 2 lines here, on the outside would be 1, 2, 7, and 8. Then we talked about a specific type or a specific pair of exterior angles. Alternate exterior angles. Okay, so alternate means on opposite sides of the transversal. So 1 and 7 would be an example of a pair of alternate exterior angles, and then also 2 and 8 would be an example of alternate exterior angles. Okay. Then the last type we talked about was corresponding. Okay. Corresponding angles are the ones that are in the exact same position, just on the other line. Meaning, if I look at angle 1, that's in the top left.
1 and 5?
So 1 and 5, exactly. 5's in the top left. So 1 and 5 would be corresponding. 2 and 6 would be corresponding. 3 and 7 would be corresponding. And also 4 and 8 would be corresponding. Okay? So questions on just those 4 relationships that we went through yesterday. Okay, so let's jump down to this example here and try to identify some of these. Now, in this example, we've got an extra line in the diagram we looked at up top. So what we need to do, okay, so for the first one, I'm looking at angles 10 and 16. Angles 10 and 16 are both on the right side here, right? So to look at the relationship between those, I can cover up this entire half of the diagram and say, well, they're both on the outside of my lines, and they're on opposite sides of the transversal. So, as Kodak just said, those will be alternate exterior angles. Okay. So, if I want to look at 4 and 12 then, 4 and 12, it will be, yep. They're both on the top half of the diagram, so I can cover up this entire bottom half. And I can say, well, 4 is in the bottom left, and 12 is in the bottom left over here. So they're in the same position, just on the other line. So those will be corresponding. My next one is 12 and 13. They are interior, right? So I'm covering up this half this time. They're consecutive interior, exactly. Right? They're on the same side of the transversal, both on the inside of the two lines. So 12 and 13 would be consecutive interior. So consecutive, if I'm looking at the transversal here, consecutive means they're both on the same side of the transversal. Exactly. Alternate means they're on the opposite. So then our last example up here, 3 and 9, here and here. So I can cover up the bottom half of the diagram this time. So angles 3 and 9, first, are they consecutive or alternate? Are they on the same side of the transversal or opposite sides? They'll be alternate, and then they're both on the inside, so alternate interior. Alright, questions so far? Okay, so now the first 3 down here in the exercises ask you to do something slightly different. It doesn't say, give me the relationship. It says, identify the transversal that connects these two angles. Okay, so let's do at least 1 or 2 of those together, and then I'll give you guys a few minutes to practice these. So this one says, identify the transversal connecting 9 and 13. Okay, so I'm covering up this left half of the diagram because they're both over here. So what is the transversal?
What does that mean?
So the transversal, remember, is the line that intersects the other 2 lines.
Then that would be line N.
So it's going to be line Q. So because we're looking at, since 9 and 13 are over here, we're just looking at this half of the diagram. So the line that both of those angles are on is Q. Right? They're not both on line N, and they're not both on line L. The only line that both of those angles are on is line Q. Okay? You see that?
Yeah.
Okay. So this one would be line Q.
So the other one's line E.
So then 5 and 14. Yeah, I think that's an L, but yeah. Yeah, so 5 and 14 are both on line L, so that would be the transversal that they share. Okay? We okay with that?
Yeah. You go to 4?
Yeah, so let's take a few minutes and you guys try the rest of these here. Okay, so we'll take 5 or 6 minutes here and see how many of these that you guys can come up with.
Especially go with it.
All right, take a look up here at the answers. Okay, take a look up here at the answers. See how you did. Okay. Which of these do we want to take a closer look at?
None, I got everyone.
Good job. Ready?
I get some more.
I thought that was a hand. No, okay.
I get some more.
Number 9? Sure. So number 9 is angles 4 and 6. So if we look up here at our diagram, 4 and 6 are right here. So I can cover up the right half of the diagram, right? So I'm just looking at, well, these two angles are both on the inside of these two lines here, and they're on opposite sides of the transversal. So opposite sides of the transversal is alternate, and then on the inside of those two lines would be interior. So alternate, interior for angles 4 and 6. Any others that we want to take a closer look at? No other ones that we want to take a look at? Alright, then go ahead and flip your paper over. So, yesterday...
Alright, guys.
Yesterday, we talked about the relationships that happen when we have parallel lines then. Okay, so on the front, we said, we're just going to have two random lines cut by a transversal. So now we're going to assume that these two lines are parallel, cut by a transversal. Now, the notation on a diagram for parallel is the same number of arrows on two different lines. So since both of these lines have one arrow on them, that tells me just by looking at the diagram that these two lines are parallel. Okay? So we talked about yesterday, whenever we have this situation, two parallel lines cut by a transversal, the corresponding angles will be the same, alternate interior angles will be the same, and alternate exterior angles will be the same. And then we said consecutive interior angles would add to 180. Right? So, in a diagram like this, if we are just given one angle measure, I can come up with the other side. Okay, so let's go through something like that real quick here. So the only thing we're given is that the measure of angle 2 is 75 degrees. So from that, I can come up with the rest of these angle measures. If angle 2 is 75, what would angle 1 have to be? Why 105? Yeah, these two angles right here that are right next to each other make up a linear pair. Right? They would have to add to 180. Well, what about angle 3 then? That would also be 105, right? We could say that this angle makes a linear pair with this one, or we could say these two angles are vertical. So these would have to be the same. What about angle 4?
75.
75, right? For the same reason. These two are vertical, these two make up a linear pair. So now since we know these lines are parallel, I can jump down here. We said, well, corresponding angles would have to be the same, right? So if angle 1 is 105, what's angle 5? 105, right? Corresponding angles are the same. Right? Then we could use that same logic all the way around. Angles 2 and 6 are corresponding. So 6 would have to be 75 degrees. Angles 3 and 7 are corresponding. So angle 7 would have to be 105. And 4 and 8 are corresponding. So 8 would have to be 75. Okay. So when we have a diagram like this, and we're looking at any relationship, either the two angles are equal to each other, or they add to 180. Those are the only two possibilities when we have two parallel lines cut by a transversal. Okay? So we can also look at the other relationships that we talked about here and say, well, alternate interior angles have to be the same. So that would be like 4 and 6. Those are both 75. 3 and 5. Those are both 105. Alternate exterior angles are the same. So that would be like 1 and 7, or 2 and 8. And then consecutive interior angles, like 3 and 6, or 4 and 5, those add to 180. Okay? And that's true. All of that is true when we look at these measures in this diagram. Right? So let's jump down to the exercises then. Okay, now on this one, we've got two sets of parallel lines in this first exercise. So, again, the notation in the diagram. Since I have one arrow on both P and Q, that tells me those two lines are parallel. And then I've got two arrows on both M and N. That tells me those two lines are parallel. The only piece of information I'm given is that angle 3 is 102 degrees. From that, we can come up with the other 15 angles in this diagram. Okay? So let's take a couple of minutes for you guys to try that. Okay? And then there are 6 specific angles that they want you to find over here. But it might be quicker just to find every single angle in the diagram, right? And then go and answer the questions. Okay, so let's take a minute and try that one.
How do you feel?
Well, how come?
Well, I knew that angle 2, this angle 1 was 102, this angle 2 was 70. Have you done yours yet? Want to do it together? Okay. Alright, you were given measure.
Alright, let's take a look here at this first exercise. So on this one, okay, we should have come up with basically every angle in this diagram was either 102 or 78. Okay, so then these would be our answers for the specific ones that they asked us to come up with. Okay. Questions on that example at all?
No, but I do have a question with the
Okay, yeah, so let's start on this one together here. So on this one, we're only told that one pair of lines is parallel, right? Just W and V. P and Q are not parallel. So we're also almost going to have to think about this as two separate diagrams. So I'm given that angle 9 is 80 degrees. And 5 is 68. So we're basically saying, well, this top half is one diagram, and then the bottom half is a completely separate diagram. Okay? So I'm looking at P cutting through these parallel lines. So 1, 2, 3, 4, and then 9, 10, 11, and 12. Those 8 angles will have a relationship like we talked about. And then separately, 5, 6, 7, 8, and 13, 14, 15, 16. Those will have a separate relationship. Okay? So we can easily figure out, these angles up here. So if 9 is 80, then 11 is 80.
100.
What's that?
So 100.
100. So then, right, 10 and 12 would have to be 100 degrees. Then we can use our corresponding ideas to come over here, right? And these would be the corresponding angles over here. We cannot say that 10 and 14 would have the same measure because P and Q aren't parallel. The only ones that are parallel are W and V. So I can come over here and say, well, if 9 is 80 degrees, angle 1 would be 80 degrees.
Now, 13 and 15 will also be 68, correct? So
Yes, yeah, yep. 13 and 15 would also be 68.
Is 7.
And then 7 would be 68 as well, yep.
And the rest is just 112.
And the rest would be 112. Exactly. Okay. Any questions on any of this stuff?